Today I'm talking about ratio, proportion, unit and percentage. Okay. I'm sure you're familiar with this topic and I'll just explain. Let me just explain it. So example 1. On Thursday, 250 adults and children attended the show. The ratio of the audio sorry to the ratio of the adults to the children was 5:1. How many children attended the show? Solution to this question is this. Just try to, they already told you here. 5:1, that's the ratio. And that's the total number of people that attended the, okay, this total number of the adults and children. So when you sum this up, it's going to give you 6. That is equivalent to 240. Then now look for the proportion. Since we are looking for the children, the ratio is 1. So that will be 1/6, which is the total ratio here. 5 plus 1 multiplied by the total number. Then you get the proportion for children, which will be 40. And the answer is A. Second example. On an architect drawing of the floor plan for a house, 1 inch represents 3 feet. If a room is represented on the floor plan by a rectangle that has side of length 3.5 inches and 5 inches, what is the actual floor area of the room in square feet? Now, okay, for you to get the square feet, you have to multiply these two together, 3.5 and 5. But we can't do that because we need to convert, because they said the answer must be in feet, so you need to convert each variable, which is to feet, each number. So now each length rather. So the first for 3 times 3.5, because we said 1 inch represents 3 feet here. So 3 times 3.5 equals to 10.5 feet. Then the other one, 3 times 5 equals to 50 feet. Therefore, the floor area of the room is 10.5 times 15, because correct it to feet now. I give 157.5 square feet. So that's the answer. Another question. Scientists estimate that the Pacific plate, one of the Earth's tectonic plates, has moved about 1,060 kilometers in the past 10.3 million years. What was the average speed of the Pacific plate during the time period in centimeter per year? Now look at it. You have to be conscious of whatever it takes to convert to centimeter per year. So look at it. Since 1 kilometer equals to 1,000 meters and 1 meter equals to 100 centimeters, now you need to convert it. If you want to convert it back to this, you just need to write this equation out. This 1,060 kilometers over 10.3 million per year. No, this is in terms of length over time. Yeah, length is centimeter over. So do that here. So look at it. Kilometer 10.3 million years. So you need to convert it. Understand? You need to convert it back to centimeter per square. And this is how you do it. Try to cancel the kilometers. See, 1 kilometer equals to 1,000 meters. So when you this one cancel each other, then this is still in meter, right? Then we still need to get it to centimeter because they're going to centimeter. So 1 meter equals to 100 centimeter, right? So you divide this meter here. So we have centimeter. Then this here must be here, it must be here. So we are done with that. So by the time you evaluate this one, kilometer cancel kilometer, 1 meter cancel meter, then we have centimeter per year. So by the time you evaluate all this, you get 10.3 centimeter per year. So that's the answer. The answer is option B. Simple as that. Then next question. Country Y consists of 2 districts. One district has an area of 3 square miles and a population density of 370 people per square mile, and the other district has an area of 50 square miles and a population density of 290 people per square miles. What is the population density in people per square miles for all of the country right now? The trick here is you need to know your formula for density. It is obvious here. See, density of people per square mile, right? So that means people per square mile is the formula of density. From here you can get that. Now, and he said there are two districts. The first district, for you to get the number of people, the mistake most people make is they just add the density together divided by 2. You miss it. That's a trap. You need to get the sum. This is more like when you are asked to calculate the mean. You need to get the sum first, add the sum up, then you divide it by then you now divide it by the number. Okay, let me just show you. So the first part, the first district number. So since people is population density multiplied by square meter, and that means the first district, the number of people will be 30 because they told you, look at it. 30 square meter, this is the square miles, this is the area, you can recall, multiplied by the density, square mile. So 30 times 3, you get this huge population. Then the second district, look at it, this is the 50 square miles multiplied by the population density, which is 290. Then you do that, you get this. By the time you add the two together, this you get total to be 25,600. Also, you add the square miles together, which is 30 plus 50, which is 80. Then you now use the original formula. Population density, because how you to look for the population density of the whole, everything, the two districts. So that will be using 25,600 over 80. I keep the 20. But the trick here is this: you need to get the population first. The people, the number of people first. Add them together, then you add the square miles together, then get the answer. Example 5. A furniture store buys its furniture from a wholesaler for a particular table. The store usually charges its cost from the wholesaler plus 75%. During a sale, the store charged the cost from the wholesaler plus 15%. So if the sale price of the table was 299, what is the usual price? Now that means this question, there is a particular price those wholesaler charge. You understand? Now they change it for a particular transaction, which is this. And I tell you the cost is this. So you just use equivalency. If you cross multiply. Okay, let me just say. 1.75 equals to x. It is the usual price. It's always plus 75. Now plus 75 means that there is the original price. Here, just as I said 1.5. 1.5 means 1 plus 0.75. The root percentage. Sorry about that. If you divide this by 100, you get 0.75. You add it to 1. We have 100% the original price without the additional, like without the plus. But when there is a plus now, you have to add it with the original. So the one that represents the original price plus the bonus, or I don't know, additional cost in this case. So the other, that explains the other one too. So since we are dealing with percentage, it has to be like 1 represent 100. So even without using percentage, you can this is the same thing as saying 175 plus x. I think we'll get the same answer, but I want to use it this way. That will be 1.75 because that's the original price. The original price is 1, and when a plus of 75% added, that's 0.75 added to 1. Then the other part too, since there is 50% increase here, so there's going to be 1, which is the original one, plus 0.15. Then you have that, which is equal to this. You're going to get the price for that. When you cross multiply, cross multiply, you have this 523.25 equals to 1.158. And you solve for x, you get 455 is the answer. So please go and learn how to use percentage. It's quite simple. Don't be confused with this data. You just try. If you put 175 here and put 115 here and still equals to 299 because you are still going to get the same answer. So don't be deceived by the same thing. Just so next question. Now look at this graph. It said a grocery store sells pints of raspberry and sets the price per pint each week. The scatter plot above shows the price and the number of pints of raspberry sold for 19 weeks along with along with a line of best fit for the data and an equation for the line of best fit. So this look at y equals to 233 minus 32x. This look like the equation of the line I used to tell you about in my previous videos. So let's see the question. According to the line of best fit, how many pints of raspberry would the grocery store be predicted to sell in a week when the price of raspberry is 4.50 per pint? So all you need to do is check this graph and look for 4 points and look for, okay, first let me just give you the logical the theoretical this thing. Look at it. This is the equation on the line. See this equation. This is it. So when you just substitute this x and put 4.50, then you get your answer to be 89. Then when you check the graph too, is there. Price per pint is there. And to look at it, 4.50, right? See, if the price 4.50, you trace this line like this place, and you trace it down somewhere around there. P is equal to 89. 89, can you see? This line. So that's the answer. That's another way to solve. So, but if you put it in the equation, you get the answer. It's straightforward. Second question: for how many of the 19 weeks shown was the number of pints of raspberry sold greater than the number predicted by the line of best fit? What they're asking you here is this. Just look at it. You see, they said the number of pints raspberry sold greater than. This is the pointer. Number of predicted by the line of best. Where's the line of best fit first? Is the line of best fit, this straight line. So any dot you see above is the answer. Just count it. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8. 8. So since the 8 points are above, and the answer is 8. That's that. So the last question under that graph is, what is the best interpretation of the slope of the line of best fit in the context? Now look at the slope. If the slope, the negative slope, you can see minus 32, that's the slope. But I taught you how to identify variables on a graph. So this will be the initial value and this will be the slope. So according to that graph, the slope of the line of best fit is minus 32. This means that the correct answer would state that for each dollar that the price of a pint of raspberry increases, because the store is predicted to sell 32 fewer pints of raspberry. So the higher the cost, the lesser what they can sell. So that's that. Then look at this question again, and this is another question. Okay, I'll continue in the next video.